Hi everyone, let's take a look at these last three laws for exponents. First of all, x to the 0 equals 1, as long as x is not 0. Bear in mind, 0 to the 0 is sometimes defined to be 1 if you're dealing with polynomials. All right, let's talk about that. What is x to the second divided by x to the second? Well, first, let's use the laws of exponents. If you divide powers of x, what do you do to the exponents? You subtract them. 2 minus 2 is 0. But now, wait a minute. What's another way of looking at x squared divided by itself? Well, anything divided by itself, almost, anything divided by itself is going to be what? What's 9 divided by 9? It's 1. So x squared divided by x squared is also equal to 1. So then it makes sense that x to the 0 is equivalent to 1. X to the 0 is equal to 1. But wait a minute. Something divided by itself is 1, as long as that something is not what number? Or what value? 0. We cannot say this if x is 0. So technically, there's a hidden restriction here. X squared divided by x squared, or x to the 0, is equal to 1. It's equivalent to 1 if x is not 0 in value. Otherwise, this here is undefined. Now, 0 to the 0, you might call that undefined. Again, sometimes it's called 1 in polynomial theory, but we'll talk about 0 to the 0 later. But if x is not 0, certainly x to the 0 is 1. What's 2 to the 0? I'll go over here. What's 2 to the 0? 2 to the 0 is going to be 1. This over here. 2 to the 0 equals 1. What's 3 to the 0? Also 1. What's your social security number to the 0? It's 1. All right. What is that again? All right. X to the 0 is 1. Now, this over here, 1 over x to the n equals x to the opposite of n. Basically, the x to the n, the power of x, can move over here if you flip the sign on the exponent, if you take the opposite of the exponent. Let's discuss that. Let's look at 1 over x squared. Now, again, 1 is x to what exponent? We're assuming x is not 0 in value. 1 is x to what exponent? 0. When you divide powers of x, what do you do with the exponents? You subtract them. 0 minus 2 is negative 2. So 1 over x squared is equivalent to x to the negative 2. In general, 1 over x to the n equals x to the opposite of n. You flip the sign on the exponent if you want the straight power of x. Now, one way to look at this, remember that a fraction has two parts, a numerator and a denominator, a top and a bottom. 1 is the numerator or top, x squared. Okay, 1 is the numerator or top, x squared is the bottom or the denominator. Now, if you have a factor of one part, you can flip the fraction in such a way that a factor on one part can become a factor on the other part if you change the sign of the exponent. Now, bear in mind, if you have a 2 up here, you don't get a 2 down here, but for ones, this does work out. If you divide x to the second on the top, you get that. If you divide x to the second on the bottom, you get that. So again, you can think of the x squared here as a factor, a part of the denominator. It is the denominator. A factor of a part of a fraction can flip to the other part of the fraction if you change the sign on the exponent. It also works backwards. If you have x to the negative 2 up on top, you can move that as a factor on the bottom, in fact, as the bottom, as x to the positive 2, flipping the sign on the exponent. So it also works backwards. It's assumed that x is not 0 here. But that's not hidden. All right, how about this? 1 over x to the negative 2. we have a part, a factor of the bottom. In fact, that is the entire denominator. This factor of the bottom can flip over as a factor on the top by changing the sign in the exponent. So x to the negative 2 down here becomes x to the positive 2 up here. And again, when you multiply by x squared on the top, you get x squared. If you multiply the bottom by x squared, you get 1. Bear in mind, we're not flipping the entire fraction, okay? So if this were a 2, we don't get a 2 down here. The flipping does work if you have a 1 in the other part. All right. Now, for number 8, I'll go straight to my explanation over here, my note. What is x over y all to the negative 1? Remember, over here, x to the negative 1 is 1 over x, right? If you forgot that, x to the negative 1 is 1 over x. Okay. We're applying this rule over here, right? X to the negative 1 is 1 over x. So x over y all to the negative 1 is 1 over this base, x over y. Now look over here. X to the negative 1 is 1 over x. When you raise something to the negative 1 exponent, you're taking the, what's that, R word? You're taking the reciprocal of the base. You're taking the reciprocal of the base. So likewise here, if you raise x over y, that base, all to the negative 1, you're taking the reciprocal of that base. You get 1 over x over y. And what is the reciprocal of x over y? It's y over x. If we don't see that, we can do this. Here's 1 over x over y. Multiply top and bottom by y over y. We're assuming that y is not 0. That does turn out to be our hidden restriction, by the way. Y is not 0. Y cannot be 0. All right, so 1 over x over y. All right, we multiply top and bottom by y. You're multiplying by 1. We're assuming y is not 0, so we are in fact multiplying by 1 here. All right, 1 times y is y up on top. Down here, x over y times y. These cancel each other out. I should put little 1s here. And we get x over here. The reciprocal of x over y, when you multiply by 1 in the form of y over y, okay, you get y over x, the reciprocal. Likewise, over here, the reciprocal of x over y is y over x. Now, you might be going, hey, wait a minute. I know x cannot be 0. How come we don't write that? You can if you want, but that's not a hidden restriction. That is what I would call, I'm using my own terminology here, but I would call x not being 0, that's an evident restriction. It's not hidden. It's in plain sight, basically. It's in plain sight, x cannot be 0. If you want to write that down, that's fine. That's totally correct. But you don't have to because it's evident from the expression, x cannot be 0. In a way, what's more key is the hidden restriction. When you look at y over x, it's not obvious that y cannot be 0, unless you look at the beginning. Hey, wait, I'm trying to divide by 0 here. Y cannot be 0. So remember, if you're ever dividing by 0, if you have a value for y that ever makes you divide by 0, then y cannot be 0, even though it looks legal here for y to be 0. If 0 is illegal over here, 0 is illegal over here, it's not evident, you should write that hidden restriction. Okay. So again, this whole deal with hidden restrictions, that'll come up when we're talking about domain. This over here, that's a hidden restriction. You should write down hidden restrictions. If you want to write down the evident ones, that's fine. You don't have to. Next, we're going to talk about the laws of radicals that are related to these laws of exponents, because you can always write a radical in terms of powers with exponents. Next time.